Okay, so 2.1 derivative and tangent line problem. Today we are only going to do the tangent line. So just a reminder, if I have a graph like this and I have a point right here, tangent line intersects at exactly 1 point. So the blue line is not linear, the green line is linear. So I can get the slope at exactly that point, but this graph is made up of infinitely many slopes, correct? So what we need to do is find a way to find the derivative at any given point, which is called the slope at any given point, which is called the instantaneous rate of change, which is the derivative problem. So we're going to start off with derivative, and then we are the derivative the long way, which we are learning today and Monday. And then I will show you, oh, look, but you can do this, and then you can be mad at me because I didn't show you that first. Okay? So the definition of tangent line with slope m, okay, is as follows. The limit as change of x approaches 0 of the change of y over the change of x, which is slope, yes, is equal to the limit as a change of x approaches 0 of f of c plus change of x minus f of c all over the change of x. Okay, so it reads if f is defined on an open interval containing c. So that means c has to be in the interval we're looking at. And if the limit here, which equals m, okay, so this is your new slope formula. Okay. Then the line passing through c of f of c with slope m is the tangent line. Okay, so we are going to find this. We are going to do this problem, and then at the end we are going to plug in c, and then we will have the slope. It's also, we also say it's the slope of f of x at c, is basically what you're finding. Remember, slope is change, right? So we're finding the instantaneous rate of change at any given point. So our first example, it says the slope of a graph of a linear equation. Find the slope of the graph, f of x, find the slope. Of f of x equals 2x minus 3 when c equals 2. So we're going to use this box right here. So we have the limit as the change of x approaches 0. So what that means, guys, this change of x approaches 0, if we take and put a point like these 2 points, yes? We find the average rate of change. And as I get closer and closer and closer and closer, my change between the x is 0, right? Because it gets closer and closer and closer together. So that's what that means. As I approach it from both sides, just like the limit works. Okay? So it says f of c plus the change of x. So that's going to be 2 times, what's our new x? C plus change of x. So, well, I have the 2, but the x is c plus change of x. Minus 3. And then the formula says minus, I forgot parentheses. I said f of c and didn't put my parentheses. Minus f of c. So now I plug in c. So I'm negative 2c minus 3 all over the change of x. Now, this is important because do I have to have these parentheses right here?
Yep.
Because I have to do what with that negative?
Factor or distribute.
Distribute. So I need to distribute the 2.
So you can't. Where'd you get it? Like what I would have done was put the 2 in for the C. Like.
No, you
you
have to
can't do
do
that.
the problem and then you plug in c.
Okay.
Okay? So do this problem, then plug in c. So then I have 2c plus 2 change of x minus 3 minus 2c plus 3 all over the change of x. What's wrong, Jaden?
I don't know.
Okay. So now that I've done that, I can zero out my 3's. Correct?
Yep.
I can zero out my c's. Yes? And I'm going to move my paper up because I feel like I'm moving clear down. So I now have the limit of the change of x as approaches 0 of 2 change of x over change of x.
Wait, why do we get rid? Oh, wait, never mind.
So the change of x's can reduce out. And my answer is just what?
2.
2. Now, if there was a c here, I would plug in, because we had c as 2, right?
Yeah.
If there was a c, I would plug in the c now. Is there a c left?
No.
No. So the slope says find the slope of 2x minus 3 when c is 2. Guys, is this a linear equation? Is that in y equals mx plus b?
Yep.
What's the slope?
2 over 1.
2. Is that what we found?
Yep.
Yes. Okay, is this feasible? We did it on a linear equation. Is it time efficient to do this on a linear equation?
No.
No, because you should look at it and say what?
2 is
2.
close.
But I wanted you to see it before we do it on a harder one. Cadence?
Let me see myself in this next. Let me look at myself real quick.
Okay, so let's do it again. Ooh, that was a not straight line. Oh well. Yeah, that's gonna bug me. Still not. Anyway. So now it says find the slope of the tangent line to the graph. Do I need to write that down? Or can I find the slope of the tangent line of the graph f of x equals x squared plus 1. Not linear, right? Okay? At the point zero, 1, and negative 1, 2. So you guys need to look at this formula. I can't show both at one time, but this is the formula we're doing. Okay? So we have the limit as change of x approaches 0. And it says f of c plus change of x. So I got to plug it in for that x, right?
Yeah.
So c plus the change of x squared plus 1. Because I'm plugging in for the x and I still have the plus 1. Then the formula says minus f of c. So minus parentheses, I plug in a c. C squared plus 1 all over change of x. So that means I have to distribute this out correctly. So that would be c squared plus 2c change of x plus change of x squared. Why did I put the change of x squared in parentheses? Anybody know?
No.
Well, it's one thing, okay? It's not x squared, it's the change of x squared. Does that make sense?
Yeah.
Okay, then minus c squared minus 1 all over change of x. So now what can I do with that?
Wait, so the plus 1 and the first one, you changed that to...
Oh, I forgot the plus 1.
Yeah.
I forgot it, didn't I?
Yeah.
I forgot that, so I'm just going to put plus 1 back here. Can't forget it. Sorry. Yes, Riley, I did forget it. Okay. Now what?
Cross out your C's.
Okay, C's reduce out. They reduce to 0.
Cross out your 1s.
My 1's reduced to 0. Now, everything left has a change of x in it. So can I reduce out a change of x?
Factor it out.
I can factor it out and reduce. So this change of x is gone. Or not gone, but it goes to 1.
Mm-hmm.
This goes to 1, and this goes down to just 1 left.
Yeah.
So I now have the limit as x approaches 0 of 2c plus the change of x. Correct?
Yes.
So now I can perform the limit because I had to keep doing it down, right?
Mm-hmm.
So as the change of x the limit as change of x approaches 0, so the easiest way to ever do this is direct substitution. So if I substitute 0 in here, I get what?
2C plus
I get 2c plus 0, so I just get 2c, which is now my, isn't it my slope? Maybe put that back up here so you know what we're finding. I'm sorry, I should have done that. Because we're finding the slope, yes?
Do those points mean anything?
They will, right now. Okay? So up at our definition, it was c of f of c, correct?
I don't know what that means.
Well, x, why?
Why can we put that?
Because c's, we're filling it in. It's just what it is. So of the points, this is c and this is f of c.
Mm-hmm.
And this is c and this is f of c. Okay? So we have the slope at 0, 1. We're going to plug in our c. So m equals 2 times, what's our c? 0. So the slope is what? 0. Then I have the slope at negative 1, 2 is 2 times what? Negative 1. So it is negative 2. So before, we would have found the average rate of change between these two, and it wouldn't have been very good, would it? like our approximation wouldn't have been very good because those points are far away. Now those points, we're bringing that rate of change, or that rate of change, we're bringing that change in the x's to approach 0. So the slope at any given point of this function is this equation. You just plug in that c. Now we eventually, Jaden, will just put that as an x. And because that's not how that works.
I went the other way already.
You went the other way already?
Yeah.
Okay, so that's all you're doing today in your problems. You are, let me show you the book, the textbook.
I don't know how to make the formula.
Yeah.
You're confusing me
I
about
don't
it.
get it. I understand.
Okay, you can't say I don't get it. I need to know what.
I don't know.
I think
Like,
I
they're your
get
first steps. I don't know what you're doing.
Okay.
I have no idea what you're doing.
Okay,
Like, I get the solving it out.
okay, so this is composition of functions. Like if I had f of 2 minus f of x plus 3, or that's a 6 evidently, I'd be plugging 2 in for x, yes?
Yeah.
And I'd be plugging x plus 6. I'm plugging in this and this. So let's get another one.
Yeah. Let's do one more. I'm just gonna watch it.
Okay. I'm just going to give the function and the points, okay?
That's fine.
Okay, so what is our m equals what? Tell me. The limit of
Change of x.
change of x approaches
0.
0 of,
Oh, you want the formula?
yeah, I want the formula, of
F of c plus change of x
f of c plus the change of x
minus f of c
minus f of c
all over change of x
all over change of x.
equals m.
And I have m. Okay, so this is what you're using. This is what you're supposed to be getting used to using. So the first time we're plugging in c plus the change of x, 4x, in the function. And then we're plugging in c, 4x, in the function I'm giving you. Okay? So the function is f of x equals 5 minus x squared. And my point is 3, negative 4. So this is c, and this is f of c when I'm done, when I get to that point.
Don't worry about those.
Don't worry about those to the end. So I'm going to be using this formula. So m equals the limit as the change of x approaches 0 of, says f of c. So this goes in for that x. So 5 minus c plus the change of x squared minus f of c. So now we plug in c. So 5 minus c squared all over the change of x. So then I'm going to have, usually I'll just write limit. I don't keep writing that, but I get bored of it. So I have 5 minus, and I got to FOIL this out right. So that'd be c squared plus 2c change of x plus change of x squared.
Wait, why do you put the other one with its own little thing? Because it's own little thing?
Okay, that made no sense to me. The other one in its own little thing,
Yeah,
little
it's
thing.
in its own little thing.
Why aren't you putting
Because
that
this whole thing is like one, it's one thing.
That's its one little
It's
thing.
one thing. Change of x is one thing.
Not stayed together
If I write it like this, it looks like delta x squared, correct? And it's the whole thing squared.
Keep it together.
Yep. Okay, minus 5 plus c squared all over change of x. So do I need to show the distributing of this separate step?
No, I got it from here. It's just,
Okay.
It's just the first part.
So this is negative now, this is negative, this is negative. So this reduces out. This reduces out.
And then your change of
And then I can reduce one change of x out of everything.
So then you have two.
So then I have the limit as the change of x approaches 0 of 2c minus change of x.
Yep.
So I get, oops, I can't put it there because we've already done it. So m equals 2c again.
Which would be 6.
And so then we plug in the 3. So m at 3, negative 4. So m would equal 2 times 3, which would be 6.
Okay, Mr. Mick, where did the negative x squared go? Why did we not put that in there?
Okay, we reduced out.
No, go up. F of x equals 5 minus x squared.
Okay, this x turns into this.
Oh.
It's the composition, it's how
Okay.
function composition works,
Okay, I
correct?
get it now.
Okay.
That's what was getting.
So that's what you're, see, those questions made more sense to me. The thingy and I don't get it, I can't answer.
I got it.